so I'll quickly, I think first 1 hour we will discuss on this. Then we will get into the hands-on session on ENVI-met. Okay. So again, I'll be rushing through because I think most of it cannot be observed in 1 hour time. So what I've thought is I have put up 15 points. Okay, so maybe if you can just take that 15 points as a marker. Okay, and then maybe you think about this in the as maybe if you have access to the presentation or even for the study material, you can reflect on these 15 points as we move further. Okay, so the first point is of course on the thermal comfort basis. Why are we discussing this topic itself on the first place? Okay, so how do we define comfort? And there are different definitions are adapted in defining comfort. Okay, so what is a word comfort? Comfort means maybe a feeling of satisfaction, a sense of relaxation, or a state of physical and mental well-being. Okay, this is one of the definitions, common definition adapted in the literature. And if we move further, what are the elements that impact comfort is something that we are interested in. Okay, maybe for example, let's say how the reflected heat from the surfaces, from the floor, and so on and so forth, how it has an impact on how do we understand the comfort. Okay, so satisfied means when the heat flows from in and out. Okay, so for example, now I think I'm sweating, so my body is trying to respond to this particular environment, right? So am I feeling comfortable or not? My body is already responding to the conditions. So what are the factors that influences uh, the conditions, and how do we understand that is what we are trying to understand in the first component. And one of the commonly adapted definition is, of course, you all must be aware by now, ASHRAE 55 standards. It says the condition of mind which expresses satisfaction with thermal environment, and it is assessed by subjective evaluation. We'll come back to this evaluation. What is an objective evaluation as we move further as well. And if you see further, if you go slightly deeper into exploring how do we assess this? So ASHRAE 55 also defines there are 6 components that has to be understood or that has to be explored in order to understand how a thermal comfort can be defined. Okay, so out of the 6, 4 are put as environmental parameters, and the 2 are put as the behavioral parameters. Sometimes you will also see personal factors. Synonymously, it will be used in the literature. Okay, so when we talk about the environmental parameters, it's ambient temperature, radiant temperature, air speed, relative humidity, and so on. And and if you see personal factors, it's the clothing and insulation values. Okay, so these are the 6 elements that we will try to understand. Uh, these are the 6 parameters which is used for defining comfort. Okay, and more precisely, Frankel's comfort model is, is based on this. And what is that's point number 1. Okay, what is thermal comfort and how do we define it? Maybe the marker can be there are 6 variables that needs to be understood in order to define comfort conditions. Okay, for environmental and 2 personal or behavioral aspects of it. Now, what is an outdoor thermal comfort? Okay, so outdoor thermal comfort is in this case we are trying to understand how the designed built environment impacts these factors. Okay, so in the previous one, if you see these are environmental factors: ambient temperature, radiant temperature, air speed, relative humidity. Okay, these are environmental factors. Now we are bringing the component of built environment to understand this together. Okay, how these environmental factors are impacting the built environment, and built environment is impacting these environmental factors, and how do we understand this phenomenon? And there is a word called thermal acceptability when we discuss about the outdoor thermal comfort, and we will use this word in all indices when we move further. Okay, what is the acceptance level? And the broad term is thermal acceptability. And if you see in the previous case, we said 4 environmental factors and 2 behavioral factors or personal factors. This can be, if you see from the outdoor thermal comfort perspective, which can be put as physical factors, okay, psychological, physiological factors and psychological factors. Okay, these are certain parameters that will help in understanding how all this will have an impact on the outdoor thermal comfort itself. So there are many studies that have been done. Maybe I've just summarized here. For example, they say what are the physical factors, how physical factors have an impact on the comfort conditions. When we say physical factor, what are the variables used? When we say physiological factors, what are the conditions used and how it is defined? And when we say psychological factors, maybe for example, uh, this is this is also part of the assessment. I think the survey when you take for perception, this will also become a part of your survey. Okay, so maybe some people will have expectations, so that will define how the comfort conditions will be. So that is also well studied and well documented. As we move further as well, we will come to know that we have very standardized format for assessing a outdoor comfort conditions. Okay, so point number two, outdoor thermal comfort. The slight addition of variables when we discuss about the parameters. Third point, most probably the important point on how do we understand the thermal comfort indices? Is it only about temperature or it is more than temperature? Okay, so primarily, if you see in the beginning, we had indices which work only on temperature as a variable. Okay, so all the comfort indices will be based only on the outdoor ambient temperature and nothing, no other the climate variables are were considered. Okay, as we move further, there has been uh, and the other factors are integrated into developing indices, which include the ambient temperature, wind velocity, relative humidity, and so on and so forth, and radiation fluxes as well. Okay, so the of those, if you see in the literature, there are more than hundreds of indices available in order to assess a thermal comfort conditions. Okay, maybe we are not familiar with all this. I put up four commonly used, and we will see that in the ENVI-met model as well. These are some of the indices that is there as a output as well. And if you see theoretically, they are divided into direct indices, rational indices, empirical indices, and so on and so forth. And of those indices, hundreds of indices, one of the commonly used, were used thermal comfort indices were PMV and PPD models. Okay, initially it was made for assessing the indoor conditions. Later it was modified and then applied for the external conditions as well, outdoor comfort conditions as well. One of the drawbacks that was highlighted was it used to assume a standard metabolic activity and clothing levels. Okay, and I hope you all have some understanding by now on what is the metabolic activity and what is the clothing levels and so on and so forth, right? So of the uh, um, of the different indices, okay, PMV PPD is one of the indices that look for. This is also there as one of the possible outputs in ENVI-met model also. There are four indices that we can make. I put all those four in the list so that we'll have some discussions on this. Okay, so and in fact, many of us we don't have access to full versions. Even in the limited version, limited trial version, we can still generate PMV and PPD results. What is PMV-PPD? I think we need to dig more. Okay, I'm just introducing the topic. Yeah, like I said, there have been many modifications done in this PMV-PPD models, and now we have more refined indices of the refined indices, and also one of the commonly used indices now is PET. Okay, physiological equivalent temperature, and physiological equivalent temperature is till we had this UTCI. Okay, till now we can say that this is one of the most commonly used indices for outdoor thermal comfort studies. Okay, and how does it read? These are again, we are not going into details of how this has been arrived on and so forth. But let us read this in the index. So let's say if you have PET values of 4 to 41, and what is 4 and what is 3 to 8, 8 to 13 degrees Celsius, so on and so forth, and how it is expressed. Okay, whether it is extreme cold condition, extreme hot conditions, so on and so forth. Okay, and this has been refined further. And if you see further, for example, let's say these are the standardized PET values, but depending on climate, this has been refined. Okay, so one of the things that we should remember is we should not take the standard PET values and then start assessing or judging the PET values of 18 I have got whether it is good or bad. Okay, we have also checked where it is applied and how it is applied, and whether it is calibrated or calibrated to the specific site conditions or not. Okay, for example, let's say we have a humid climate, probably we will use this more often. And in fact, when we did a study in Vijayawada, we refined this also. We had different results, uh, not substantially varying results, but there was slight differences even in uh, uh, this comparison as well. Okay, so for example, let's say pool. Okay, maybe it's 18 to 22 degrees Celsius. Okay, it may be 12 to 15 degrees Celsius. Okay, maybe let's say we say slightly warm. Okay, you can see that we can relate this, right? 26 to 30 degrees Celsius or 30 to 34 degrees Celsius, we are still okay. Okay, we are still okay with this. However, it may not be same case in other especially cold countries or cold regions as well. So when we say we are using PET as one of the indices, please make sure that we use appropriate index, and make sure that it is applicable for or adjusted for the particular climate conditions. Third, and which is more often used now, is UTCI, okay, Universal Thermal Comfort Indices, where it assumes that the air temperature is equal to the mean radiant temperature, relative humidity at 50 degree, 50 percentage, wind speed of about minimum zero point 0.5 meter per second, and metabolic activity of about 135 watts per meter square. Okay, and this is more commonly used now in the literature. Okay, uh, PET and UTCI is something that you can look for if you want to assess an outdoor thermal condition as such. And again, PET also has a range. Okay, how do you read this, and what are the when you get a value of about 39 or 27, what does it mean? Okay, similar to other standardized results, we also have some interpretations for the output that we get. And if you see overall output, okay, we have on one side, you can see this. These are called direct indices, where only temperature and humidity, okay, and temperature and some other factors, humidity or only radiations are taken into consideration. In some case, all environmental parameters, for example, ambient temperature, the wet bulb temperature, solar radiations are taken into consideration. In some cases, or where we are more interested in, where the physiological conditions are also taken into consideration. Okay, so if I put this further, we have something called objective evaluation, and we have something called subjective evaluation. What is an objective evaluation? Which we can measure using instruments. I think you had a question before we learned on how do you measure things. So objective means we can measure it. Anybody measures, you get same result. Okay, so objective measurements, part of the outdoor thermal comfort assessment or part of outdoor thermal comfort study should have objective assessment and supported by subjective assessment as well. Okay, we can't depend only on one aspect. Okay, we have to have balance of both. Only then we'll have a meaningful output in this case. Objective assessment, ambient temperature, wind speed, relative humidity, solar radiations, energy balance. Okay, this all you can put it under. microclimate. It can be measurements or modeling, simulations. We will see part of this in ENVI-met as well. Okay, physiological conditions. Okay, we have some uh, methods, maybe monitoring, modeling, observation. Based on this, these values can be taken. And subjective evaluation, okay, where we have to understand what is the clothing level, what is the preferences, okay, how people are using the space, what is the expectations from the space, and so on and so forth. Okay, and this will also maybe it can be recorded in the form of observations or any predictions or surveys, interviews, and so on and so forth. Okay, in all cases, we need this both. Okay, we need objective assessment and also subjective assessment into considerations. Okay, now if you see the scale of measurements, okay, I put a scale and temperature threshold for particular thing. We have on this side we have thermal stress. I put WGBT here, PMV, SET, PET, okay, and UTCI. And you can relate when we say extreme cold, okay, and some of the indices you can see it can record only to certain levels. Okay, maybe it's 5 point scale, maybe 7 point scale, or maybe 9 point scale. Okay, so UTCI is more commonly used where it has 9 point scale. We can have a thermal stress recording, maybe from extreme cold to extreme danger conditions, and so on and so forth. Okay, so this is again relevant and important when we develop the questionnaire survey as well. And if you see the indices itself, we have something called UTCI, okay, set, let's say RPET, okay, and PMV, and you can also see the how the thermal stress is expressed in terms of the figures or values. And where is it used? I have put some reference here. The ASHRAE 55 says what is the range in which it has to be measured, and then these are the other studies that has been done where these ranges have been used for studying and then recording the data, which means we have a set of indices. We don't have only one answer. We have multiple indices which we can use for studying this. Okay, instruments, I think ma'am had shown hands-on. Okay, maybe you must have checked. There are different instruments used for studying the outdoor comfort conditions as well. Okay, that's point 10. I think I'm not mentioned, but I hope you have written it. Yeah, and I think I'll just pass through. Okay, different instruments and for recording different aspects of the temperature. Okay, last part of the presentation. Uh, First, we should know how do we record the thermal perception. Okay, maybe we should understand the different indices available and what are the thermal stress range that we have. Okay, that's one part. So we have discussed environmental parameters, okay, and then behavioral parameters. The third point, okay, when I said when we check the definitions of outdoor thermal comfort, I said we are interested in knowing how this built environment and the environmental parameters have an impact. What is the relationship? Okay, so here again, so understanding of this is crucial. Okay, so there are different studies again. There are different scales of studies that can be taken up when we talk about outdoor. I won't say outdoor thermal comfort study, but outdoor heat stress studies and so on. Okay, so which may include from something called urban boundary layer studies or rural boundary layer study or canopy layer study. I think I was told yesterday you had a session on large scale models. Yeah, so you can relate this to maybe how heat is perceived or heat is dissipated or understood at a city scale. I like this diagram. I present this all the presentations I get a chance to. Okay, so heat island study is done at city scale, right? we are not interested in doing something at city scale. We are trying to understand part of city. Maybe let's say if you take a zoom portion of this, we are interested in doing something at this scale. Okay, maybe in a technical term is called the canopy layer study or canopy layer heat island study or any study that we are interested. Below that also there is a layer, okay, that's building an immediate building environment. Okay, maybe many times architects end up doing something at this scale. Where we are interested in site and site related activities only. Okay, and canopy layer study is slightly extended version or a slightly extended scale, maybe neighborhood scale or a group of streets, cluster of streets are being studied in this. Okay, this is also this understanding is also required as we move further. Okay, yeah, and if you see from the climate perspective, we call this as micro scale or local scale or meso scale. There's a there's different terminology that is used, and this table will also be useful to figure out what is the scale in which we are trying to study. Are we studying about a building facade? Are we trying to understand how the treatment of a building facade is having an impact on the immediate context? Or are we interested in understanding building and the elements? Okay, maybe the scale can be 10 by 10, or the scale can be 30 meter by 20 meters, and so on and so forth. Is it a canyon? So on and so forth. Okay, so this positioning is important because this will help in understand what kind of data is required. Okay, and also what kind of assessment technique that we can use, what kind of uh, tools that we can adapt will also get streamlined if we know a clear idea on what is the scale in which we are trying to do this exercise. Okay, and in ENVI-met, I think probably we end up doing any one of the three, or maybe the second and two. Okay, so maybe a neighborhood or maybe a cluster of streets can be something that we'll be trying to study. Okay, now that's the scaling part. The second part of understanding that is required when we talk about building is the energy balance that takes place in the urban environment. Okay, what happens to the heat? Okay, what happens to the all the heat that we receive on an urban environment? Where does it get stored? How much it is getting stored, and how much it is getting reflected back? So if we go further, I put three components, three or four components under this building component, uh, building section. How the energy balance should be understood only with respect to build form. Okay, so maybe we start from building to a larger scale, maybe let's say block level. First component that we should have an understanding on is the height to width ratio, the aspect ratio. I'm giving you this picture, this theoretical understanding, so that when we go for solutions also, we have to come back to this. What is the aspect ratio? What is the surface treatment? What is the height of the building? How much setback required? So on and so forth. Okay, so this is essential when we, let's say, maybe we have come out with some assessment and results. How do we improve this? How do we improve this urban conditions? Again, we have to come back to the basics. How do we play with the geometry? How do we place the green? How do we place the blue? So on and so forth. Okay, so which means we have to have an understanding on how the height to width ratio plays. What is the role it has in on heat absorption or heat dissipation? So on and so forth. Point number one. Point number two, we should also know how much is the sky view factor, how much of the sky is visible, and do we need visible sky or we don't need visible sky? Again, it will depend on the climate that we try to study, and uh, this understanding is also essential. Third component within this, the orientation part. Okay, how the layouts are oriented. Is it oriented on the windward direction, not windward direction, and how do we change it, and what kind of permutations and combinations that we can bring in this aspect. And the I think numbering, yeah. The other aspect that we should also know is the albedo values. Okay, how the surfaces are treated. Different different surfaces have different albedo values that will have a this will behave a different way. Okay, maybe if you have grass, the the kind of interaction that it will have is different from a paved surfaces. Okay, and again, these are already standardized. We don't have to come and invent or come out with some new numbers. These are already there, well studied, well documented, but we should know that where to get the information from and what kind of values to be used and when it is to be used. I put all that here, maybe for grounds, what is the value? If it is low vegetation, what are the albedo values? And if it is water, if it is roads, walls, roofs, windows, and so on and so forth, albedo values that we can uh, use. Second component after building is, of course, on vegetation and what is the role of vegetation, how much vegetation should be given, and in which combination it has to be given, and what is the size, shape, placement, okay, and all that uh, has to we have to have an understanding on. And in ENVI-met, if we, I was telling in other sessions as well, in ENVI-met, we always model buildings only, right? We can model buildings, walls, roofs, windows, and so on and so forth. We can model trees in ENVI-met. That's the advantage. Maybe if you have documented real trees and if you want to replicate as realistic as possible, there's a possibility of recreating the trees in ENVI-met model and then try to import that into the simulations and check. And also on the water component and how water component will have an impact on again same what should be the size, shape, placement, and how it will have impact on the overall assessment conditions as well. And the fourth component, building, vegetation, then we have water, and the fourth component is air, movement of air, and how ventilation will help in dissipating the heat in most of the cases. Okay, we are all biased towards humid conditions, so how do we dissipate heat? That's our agenda. So there is one thing that we should remember. I don't have slide to explain that. For example, let's say um, on one side we have heat stress, okay, and other side we have something called cooling elements of city, okay. Naturally we use vegetation, water, and air as cooling elements in the city to dissipate this, okay. And this we can relate with buildings also. What happens, let's say if we are humid, if we are not comfortable, what do? We turn on the fan, meaning we are trying to increase the ventilation rate. Similar thing, or we can apply this analogy at city scale also. How the vegetation component will help in balancing the heat, how water will help in balancing the heat, and how we can improve the ventilation in urban areas. Okay, and we talk all this through something called urban climate maps, where we have in one side we have the thermal stress regions. On the other side, we have something called cooling potentials of city, which we can use to balance this. And we do this kind of studies for different heat islands and so on and so forth. I think I'll just skip this. And there are different mitigation measures, okay, that are applied to balance the heat. And I used to discuss this graph as well in the sessions. For example, let's say this is you can see the this is for the overall daytime temperature, air temperature, and this is daytime surface temperature. And this is for the night time. Okay, you can see the surface temperature and the air temperature. What happens? Theoretically, you can say that there's not much of a difference in air temperature. What is the cause of concern is the surface temperature, okay, that varies throughout the day. Okay, and if we, of course, this is not a technical section. Okay, it's a conceptual section, but it helps we will be able to understand the concept that we are trying to impose here. For example, let's say we have water bodies here. You can see different phenomena happens within the day. Okay, during the daytime, a lot of heat is observed. Okay, and the surface temperature is actually equal to air temperature. Whereas during the night, okay, the surface temperature is actually more and more than the ambient temperature. Okay, and let's say in the core cities, we can see the ambient temperature is actually equal to the uh, uh, ambient temperature is equal to the surface temperatures and so on. Okay, so this phenomenon has to be understood. Okay, different urban settings will behave in a different way. Okay, that's why we have something called the urban canopy layer assessment, where we try to understand what is the canopy composition and how it will have impact on. This is again a simple explanation of how different indices or different parameters that can be studied in an urban setting. NDVI, I think by now you all must be familiar what is an NDVI. And when we talk about the urban environment, we also look into how building coverage ratio or relative height ratio and canyon effect, albedo values, sky view factors, and all this have an impact. All this can be understood. And there are different tools also available. I think Rayman maybe is not part of the discussion, and you can try this also. Okay, so where you can, you will come across the same parameters. Okay, air temperature, relative humidity, and your wind speed, and you will be able to assess in a simple way the what is the how much is the exposure and how much what is the PET values and SET values and so on and so forth. Okay, this is a simple tool that you can try, and of course we have a sophisticated tool ENVI-met where we can do this kind of assessment in a more precise manner. Yeah, I have put one case study here, I think two case studies. One is a neighborhood assessment in Hyderabad. Okay, the idea was we wanted to let us say before I explain the case, let us say we have a study. Okay, we have taken a neighborhood, and then we study this is a green patch, and there is some stream, and these are built up area, and then we have done an let's say ENVI-met assessment, and we came out with some interpretations how this is there. Now, what can be the possible solution? Maybe we can come out with some greenfield output, right? Okay, let us put green here. Let us have water bodies here. Let us build buildings all around. Okay, maybe it is possible in the greenfield development. Okay, let's say if you do this kind of assessment for let's say hundreds of layout, okay, and then can we generalize this? Can we have a generalized design guidelines which can be adapted in similar neighborhood conditions? Okay, so many a times we do this kind of study. The intention is not to study this part, maybe to study similar such spots, and then check whether there can be a commonalities in having green, having size, what is the size of the green, what is the proportions of green, so on and so forth. So we were trying to relate with this. The Can we change parameters in zoning regulations so that it can be applied throughout the other settings as well? I think I'll not explain this. The parameter system. Maybe this is more relevant and maybe more appropriate since the session is on the thermal perception. So this is one of the study we did in Vijayawada. Okay, this is the study. This is descent road. Okay, and half of the descent road is about 500 meters in length. How did we study? I said there are two components of study, right? First is the understanding the built environment. Second part is the perception. Built environment, okay, so we have mapped the entire study in terms of aspect ratios, different aspects. Within the street there are different aspect ratios, okay. Some are tall buildings, some are low rise spread buildings, and so on and so forth, okay. So you can see there's a continuous building, and different aspect ratios are being created here. So what we did was we studied, uh, we identified 6 points of observations in the street. Okay, within 6 points as well, what we have done is we have measured on 3 spots. Okay, let's say if this is the entire street or point of observation, one on the edge of this side, one on the edge of this side of the building, and one at the measuring point at the center of the street. And we did this kind of assessment for different aspect ratios based on the existing conditions. Okay, and also we have mapped what is the surface material that is used and what is the finish that that is there, and we took it to ENVI-met, and then we did a assessment. We have done a thermal assessment. On the other side, we have also taken the perception surveys. We have conducted the questionnaire survey on the pedestrian users. Okay, how they feel and the what is their perception of the thermal environment at that particular point of time. Okay, similar such studies can be carried out, or similar strategies can be applied for conducting this study. This is another example. We have done some studies on how heat is perceived in low-income housing settlement. Okay, this is again on one part we can do simulations and then model how much heat ingress happens. Okay, and what is the how heat is accumulated and when it gets uh, thrown out and so on and so forth. And we have also conducted in-depth primary survey interviews with the users, how they perceive heat and what is their understanding of the heat. Just a quick example. This is a simulated result for one of the cases for all 365 days. What you can see here is the gray part is the ambient temperature, average dry bulb temperature. Sorry, average is the number. The gray part is the ambient temperature that you see for throughout the year, and the red line that you see is the observed temperature inside the building. What we can observe is, although the average temperature, average dry bulb temperature is about 28 degrees Celsius, but the indoor temperature is always above the ambient temperature, which means the houses are always uh, hotter, warmer than the ambient temperature itself. Okay, because of different conditions, we are not going into depths of it. But this is one aspect. But if you do a survey, this is another extreme that we should also keep in mind. They are not bothered about it. Okay, although if you put these values into PET and UTCI, we can still classify this as hot, and it's not okay for living, so on and so forth. But they don't. They have different issues, so that gets submerged when we compare with the results. There are some examples and how we have done. I think we also use this surface temperature thermal imager to record this as well. I think you have seen examples of that. Okay, so I'll conclude the first part. First, we should know the basics of thermal comfort. Okay, what are the variables that we are trying to assess? And there are different indices that we can use for, or maybe let's say here, you we should register something that we should understand the environmental parameters, we should understand the behavioral parameters, and the built parameters. Okay, built parameters in environmental parameters, temperature, humidity, all climate variables. Okay, in the behavioral parameters, the clothing values and the metabolic rate and so on and so forth. In built environment, we should know the aspect ratio, your orientation, the albedo values, and what is the vegetation, what is the water component, and what is the air component in that. Okay, so all these things are essential before we proceed with the assessment itself. Outdoor thermal comfort indices, there are different indices. Most commonly used now is UTCI, and PET is also still used, and you will find papers where PET is still as on date as well we use. And all the not all, I think now all the outdoor thermal comfort assessment include objective assessment as also subjective assessment as well. Okay, so it's not only evaluation or only simulation part. It has to be supported with subjective evaluation, and we should have a thorough understanding on the energy balance that takes place, and probably some mitigation measures that we can guide in the overall one. And we discuss all this under climate responsive planning and design, and I believe this is a multidisciplinary uh, understanding is required to do something on this aspect. Okay, so with that, I'll stop the first part, and I have some advertisement. So we have developed some NPTEL course on these subjects. Okay, this was funded by British Council. We have developed a course called Climate Resilient and Energy Secure and Healthy Built Environment, and where we have developed courses on urban climate scales. You can see courses on urban canopy models. You will see courses on outdoor thermal comfort, and courses on energy efficient neighborhoods. These are free courses. You can register, and then hosted by IIT Madras. You can check for. I've run through the slides, but more discussions and more detailed presentation is made in there. It will be useful for you. It's NPTEL, yeah, yeah, plus, yeah. There's NPTEL, okay, NPTEL plus. This is NPTEL plus. Okay. Okay. Yeah, it is. Yeah. Okay. I think I'll stop here. If you have any questions, we'll take. Otherwise, we'll move to the next part. No, introduce. Okay. So in the second part, we are interested in understanding ENVI-met. Okay. And I know this is slightly old version. Today morning I upgraded. It is 5.6. 5.6. Okay. So like sir was saying, maybe January we may have 5.7. Okay. We don't know. Last time when we introduced it was 5.4. Okay, so some upgrades are there, but not overall structure remains same. Okay, so we'll just see what is to be done. Yeah. What they have written is, of course, we are not promoting ENVI-met. Okay, this is tool available, so we are using it. So we don't have any tie-ups with ENVI-met and all. This is for academic exercise, and I think this is one of the tools where we can get more precise results, and that's why we are also encouraging students to explore this particular tool. Okay, so one probably you make note of this one. Normally, we end up going into the commercial website, okay, envimet.com, I guess, where it is about the software. Okay, we have a website called envimet.info where we have all the technical aspects of the. Okay, I'll take you through this. What? If you go to ENVI-met info, okay, you will see a dialog box like this, or the screen like this, where there'll be there'll be descriptions about how do we start with the tool, and there's a description on what is the model architecture. Model architecture means how the entire software runs and what is the basis and so on and so forth. And different applications where we can apply this particular tool, and there are some case studies as well, okay, that you can find in the e-libraries and of course downloads part. And if you see the start, okay, we have certain things. I'll tell you which one we should definitely read a little bit so that we have an understanding on the tool. You can check, these are the things that is there. ENVI-met as a holistic model, and probably uh, an overview about the tool, what are the different files and formats that it supports, and so on. And if you go to the next part on downloads, this is a download thing that probably you all can do it. And you also have an examples here, okay, without making any models. We can in fact download certain models and then check how it is run. And you can also find results, already results in the form of PDF and so on. You can relate, you can check how things work. Most important part is here, how the entire software works and what are the different components that is there. Okay, that is gone in, or that how the tool works itself. In terms of applications, okay, we will see this when we go to the software as well. There will be there's something called headquarters. Okay, that's where all the tools will have an access to, and then we have something called MON. Okay, this is for modeling. There are two ways in which we can make models in the ENVI-met. One is MON, and the other one is the spaces. Okay, so this two uh, platforms are used for making models. And Leonardo is for reading out the results that we have simulated. And this ENVI-met core is where simulation takes place. And ENVI-met is post-processing of some of the results. Very quickly, we have this is a kind of a headquarters. That's why probably they have named it as headquarters, where we have all this tool together. First, we have to launch this, and then we will get all this other subtools. Mode and spaces are used for modeling the spaces where for which we want to do an assessment. Okay, this you can put it as modeling environment. And ENVI-met core is where actual simulation uh, is assigned, or simulation is done. And once the simulation is done, we can read that simulated results using Leonardo. And ENVI-met is something where we can do the further processing of the results. Specifically, you can see here already PET, UTCI. If you want to generate, we have to go for ENVI-met. And in case of trial version, we still have an access to PMV PPD outputs that we can generate. Otherwise, we need full version for generating results on PET and UTCI. And in the application, we have some more tools. One is called the database manager, okay, where the filing, how the files are stored and how it has to be structured. That is one part. The second part is Albiro, where we do the vegetation models. Okay, so if you have a specific vegetation that you want to model and then bring it to the software, bring it to the ENVI-met model, we can do that here. And also maybe there are already existing trees and grass and so many vegetations are there. If you want to modify certain parameters and then use it, we have to go to this particular platform and then get that work done. Then we have something called force manager, where we try to assign, for example, there are three ways in which simulations can be done. Okay, I think you have taken the measurements today, right? So it is probably, let us assume you have taken measurement for 1 hour. Okay, you have recorded continuously temperature, humidity, air velocity, and radiation for 1 hour, and you have the Excel data with you. Can I use that for simulation? Answer is yes, we can use that for simulation. We have to know where to give that as input. Okay, so there's one part where we can do this kind of modifications in the weather file itself. Okay, there are one in the beginning you will find that it will be simple. By default, we can modify only temperature, air velocity, and one more parameter, relative humidity, and then we can run simulations without changing much of the parameters. In second case, we can bring in the weather file and use it as it is. In the third one, in addition to weather file, you can bring in our own field data and then modify and generate results. Okay, so depending on how much understanding we have, we can take this further. ENVI guide is for simulation, and these are again for project management and so on. And we have QGIS plugin as well. I have not used it. Maybe if I use sometime, we'll see how. I don't know how it works. And if we are successful, and we should be able to at least get output like this, okay, where we have buildings, okay, and we are able to plot different temperature profiles, and we should also be in a position to profile, map, and show how the air velocity or wind direction and wind moment takes place in and out. Okay, so I'll come back to this later. Let's go to the tool. Okay, I have already opened it. Okay, so maybe let's say if I just, there's something called, if you go to I think I'll introduce, then we can go to the full version. Okay. Okay. I'll take 45 minutes now, and then introduce. Then we can. Okay, you have, once you have installed the software, or maybe let's say before I do, this is the website. Okay, so normally we end up here. Okay, it's envi-met.com. It does not have, it's only about product. Okay, you go to ENVI-met info, where we have these information, where, for example, let's say I go to applications, and probably, let's say, I want to know how spaces work. Okay, all descriptions, technical descriptions are given in this particular website. This is a handy reference. We should, if we have anything that we should come back to this technical website and then uh, look for answers. And this has got more elaborate um, explanations as well with examples are there. In fact, we can follow that if we get any issues. Okay, now let us go to the tool. Once you have installed the software, okay, it's ENVI-met, and there are so many um, other tools that it's installed along with that. Open headquarters, okay. So I think I'm opening old version. Okay, so we have the ENVI-met headquarters. In the first tab, we have mode. Like I just said, these are this and mode and spaces are a platform for modeling. Okay, and then we have something called simulate and we guide. Okay, where we assign how much time duration uh, the simulation has to take place and so on and so forth. And NV core is the core simulation platform where simulation takes place. And post processing for PET UTCI, there is a specific direct tool. Okay, that's why this is famous for outdoor comfort studies because it is one of the intent of the tool is also is to support outdoor thermal comfort studies. And with Leonardo, we can see us already there. Visualize. We can visualize the simulated results using this particular tool. And in the data setting, we have something called project workspace, data managers, Albero, and sourcing manager. Uh, this this is the first step that you should also be doing. Okay, go to the project workspace, and you should create a workspace. Okay, where you want the files to be saved. Okay, so one of the output maybe. See, once you make the any file, once you make a file and run simulation, you will get so many outputs. Okay, and the tool expects the all the files to be in the same folder. Okay, many a times we have an issue if you change these directories, we'll have lot issues. It will not get results. We'll have errors and so on and so forth. So always keep this in mind that the workspace uh, all the output that is generated, the base file that you create is all in the same workspace. We'll come back to this one by one, but I'll just go through this. And the systems, these are just some information about the tools here. Okay, now first thing, let us assign a workspace. Okay, maybe let's say I have a workspace already here. It is ENVI-met. Okay, and I'm still using the same workspace. Okay, then once we assign the workspace, we have something called create projects. Okay, so go to create project and let's say, okay, a new folder is created. Let's go here. You can see a new folder has been created, probably where we'll do all the we'll use this as a base and run all the results or generate results and then further process it. Okay, so this is the first step. Okay, make sure to have the same uh, workspace, and then all the files are there in the same uh, workspace. Okay. On the other side, we have other things. Before we launch into the actual model, you go to Database Manager. You can see that there are so many parameters here. Okay, what is the soil type? Okay, soil and ground material, soil profile. Okay, plants, wall and roof material. Okay, uh, construction technique, greening, single walls, full skin color. Okay, so for example, if I go to the soil, if you go here and look for answer, look for the further the files. There's so many inbuilt materials are available. Okay, for example, let's say cement, concrete, asphalt, okay, granite, brick, so on and so forth, and then their appropriate uh, physical properties are already given by default. We can use it as it is. Or let's say if you want to modify some of the materials, okay, we have don't modify. I don't think you'll be able to modify directly. You have to create a copy of this, okay, and probably you can modify here if you have a specific uh, values taken for that, and then you can edit this and use it in your application. Otherwise, it's not. Yeah, anyway, it's not editable. Okay, if you want to edit, you have to make a copy of this, and then you can make your own library for assessment. Similarly, you can do for other aspects as well, how the surfaces are to be treated, what is the road materials, and the appropriate values are already there. Okay, so you can use it, or if you have custom material, you can assign that appropriately. Third, we have something on the plants. Okay, for example, grass, there is some predefined values for the grass. Okay, and some other specific materials is also there that we can directly use. Or if you have a new material, if you have documented a new tree or vegetation that has to be modeled, I'll tell you how that model can be done. In terms of walls and roof materials, you can again see we have a different library, cement and its appropriate properties, and so on and so forth. All this again can be you can directly use it, or if you have some specific material from the market, that can also be done. Fourth component, we have wall sections as well. For example, let's say you have concrete wall. If you double click concrete wall, okay, and it helps you in understanding, or it tells you what is the width of the wall and how each of the layers are made. Okay. Suppose you have some wall sections, okay, that you have to make. Okay, you can do all that. Maybe let's say there's a brick wall and there is some insulation on both sides. You can adjust the you can adjust the thickness. All that you can do. All that is possible in, and then you can customize this appropriately. Yeah. So directly, if you edit, it's not possible. Okay, you can't edit this. Okay, you need to make a copy of it into your own folders so that it can be edited, and then you can use it. Similarly, for the greens, there are certain specific output. There are some specific, yeah, it's already, it automatically. Yeah, if you, yeah, that's what. If you have materials from site, or if you already measured certain things and then you want to use that as a wall, maybe you have measured a wall which is 450 mm. It's not big, so we can do that line. This is line wall geometry. Yeah, we can edit it. Basically, we can have control on thickness, material property, all that. This applies not only for the wall material. It applies for the other vegetations as well, uh, because it understands as a layers only. Okay, so this is one thing that we should keep in mind where we can do the assessment. And I think in last session there was some question on how do we bring in pollution data. Okay, so there is a scope or there is a possibility of bringing very detailed uh, PM 2.5, PM10, and all measurements if you have taken, all that can be brought in as an input for simulating the in ENVI-met. Okay, so this is uh, one sub tool where we can edit the materials, where we have a material database for. Okay, second one is Alviro. I'll go here. Okay, so we have some materials here. Okay, so for example, let's say I bring in some trees. Okay, so you can read how you can visualize this in first 3D. Okay, uh, what happens in X, Y, Z plane, X, Y and Z plane. You can see the red line here in the bottom. Okay, this is okay how the foliage characteristics is measured or modeled in minute. Similarly, since it is a three-dimensional model, you can see this is on the XZ plane, okay, and this is on the other side. Okay, different. How, you can understand how the models are made, basically. Fine. So again, you have a huge database here. Okay, maybe the landscape architects, if they have any specific trees that we have measured or observed some certain things, if you want to model modify, that is also possible here. You can edit that and then use it as your primary model. Okay. Then we have something called force manager. We will come back to this little later. Or we'll come back to this. How do we assign specific weather file? For example, EPW files and all if you have, how do we bring in and how we can assign for this particular aspect? Now let us go to the main tool for modeling. First is I'll also show this more. I'll go here first. And those who know JS, how many of you know JS? Yeah. So this will be useful. I think we can bring in, I'll show you some examples. You can see how what we can do using this. This is a workspace, okay, about you can see here 2,500 meters by 2,500 meters. And let us say if I was trying to assign in the morning, let's see if it works here. Go to the world setup, okay, and it didn't work. Let me check if it works now. Let's say Chennai. Yeah, it worked. From morning it did not. So it's good. Fine. So what we can do is, okay, before I jump into this, for example, let's say this wide area, the working area that we have, it's like a grid now, the space. Okay, by default, it is 2,500 meters by 2,500 meters. And we know that we have the free database Google has, Microsoft has. We already have a database in hand. OSM, OpenStreetMap data is also already there. Now, instead of we drawing something, can we directly bring already existing 2D drawings and then start from there? If that is the question, Mond is the platform. Okay. So what we do is, let us see if you can make something here. I'll use this as a test space. Find locations. Yeah, Vijayawada. Okay. Select Vijayawada and you can see it is taking no appropriate platform. Set location. Okay. Okay. So we have assigned this space, assuming we have this assigned this workspace as Vijayawada. Okay. And those who work with JS, they can know that the WJS 84, and you can see lat long in the entire space. Okay. Now, what we can do is, what is the advantage? Let us go to now input OSM. Sorry. I have clicked on get OSM data. Okay. Uh, since we have assigned the my world as Vijayawada, okay, so it is directly taking to that space. Otherwise, we can do the other way also. Let's check what it shows. We have to check. Yeah. So we have the database. See, so part only. Okay, it's not full part of the data, but still it's good. Okay, so let us see. Such a big scale, exactly. Yeah, correct. Yeah, yeah. So this is one aspect that you can do. If you see here on this side, okay, This is the 2D database, okay, free database that we have. Maybe it may, this is an OSM data, and we all know, I guess, OSM data is realistic data, okay. So, but something to start with, we can use this, we can depend on this, or the other way is, if you have a database, shape files, already shape files, you can bring in that. Okay, that is also possible. And only thing, yeah, maybe I can show, but I have to search for the shapefile. Only thing that we should keep in mind is what is the area that you want to specify. Okay, whether um, the entire area, or maybe like we have said 2,500 meters by 2,500 meters, or little less than that. That can be the base for it. Okay, fine. So now what I'll do is I'll also bring the, when I was introducing this earlier as well, mm, there will be one question on how do we get the topography. That's how we get the topography. So we can do that. Okay. Now we have this big database. Okay. Let us assume that for the same place, we get a topography. We have your information here, get topography. And by the way, if your workspace is only 50 by 40, 50 by 50 by 40, these are all meaningless. Okay. That is too small area. In free version is 50, 50, 40. Okay, and in that also, if you read little technical thing, what they say is uh, we need to have half of the space for simulation. Okay, don't build 50, 50 and 35 as built up. Okay, so if the entire grid size is 50, 50, 40, we should be building about 40, 45, 40, 45, and maybe 20 meters, 25 meters. One third should be left free for simulation, otherwise we'll have errors in the model. Okay. So, but these are possibilities are there. Okay. Maybe if you are doing research, you can buy software and then see whether you're able to get it. So by default, okay, there are three. Oh, okay, there's so many now. Uh, okay, so there are so many database here again. Okay, whether it's 90-meter resolution, 30-meter resolution, SRTM data. Okay, more commonly used. And we have, I think, Copernicus database as well, 90-meter, 30-meter resolution. Okay, so 30-meter, let's say I'll import SRTM data. We don't have to do much since we have assigned the platform, and we'll be able to generate the base. Yeah, definitely. No, no, yeah, we will do a small model only, but I'm just telling you there's a possibility of making maybe. Yeah. Hmm? No, no, no. 3%. Okay, so perfect, wonderful. Yeah, yeah. I was praying in the morning, it didn't work. So you are lucky. Only during the session. Yeah, yeah, good. Uh, no, it's not Kannada. This is Gunadal. Gunadal. Yeah. We are here in campus. I think maybe you can do this part. This part you can do actually. Okay, I'll. But I'm happy. Okay, some results have come. Because I have not tried. I tried in the morning because I thought I'll just be sure whether we get the results. I did not get it, but anyway, fine. Yeah. But I'll tell you the other thing is okay, fine. What we have done so far, we have just given the work workspace. Okay, we have assigned where we are working, and then we went to OSM data and we have imported OSM data. Okay, you can also do import OSM data directly also. Let's say I have done that in the morning. For example, you can go to OSM. Uh, okay, so I think these are familiar, I guess, right? So you can just assign the area, uh, download the OSM file, and then you can directly import that here as a base file. Okay. Okay, fine. Now, next step is how do we convert from here into the ENVI-met model? These are again base models. We can't directly take this into the spaces. Okay. So what we have to do is before we actually go there, there's something called sub areas. Okay. I go to the sub area and then I go here and then click which is my area where I want to study. Okay, maybe I'll just say I want to study only this part. Okay, let's say, okay, that itself you can see it is 1155 cross 730, 728. Huge. Hmm? So now what we can, I'll tell you one more thing just before we move further. Okay, so in the simulation tab, we have something called create mode. Okay, and it tells us, okay, for example, let's say if you go to in this tab, simulation tab, okay, and say we have two things here. One is create ENVI-met model, export ENVI-met model to INX model. Yeah, maybe one thing that we should keep in mind before we go, we need three or four files. One is called INX file. Okay, these are model files, hmm, building, vegetation, so on and so forth. Okay, we also need something called CIMEX file. These are simulation files. Okay, so INX file will tell what is the building, where are the buildings, and how tall is the building, what type of vegetation, what is the surface, so on and so forth. CIMEX file will tell how long the simulation should take place. It should be 1 hour simulation, 24-hour simulation, and from when to when the simulation has to take place. This has to be done. These are two major requirements, and then once we have this, we will be able to generate results. Yeah, CIMEX file and INX file that you keep in mind. Okay, I go to simulation and say create ENVI-met model. And if you come here, we have build surface area from where I have already assigned study region, smaller region, and it says if I keep this resolution as it is, okay, horizontal resolution is about 2 meters. Is it visible? Yeah, its horizontal resolution is about 2 meters, and which will result in 550, 580 by 360 grid. Okay, still higher than what we have. How do we change this? Now I'll make this vertical resolution by, let's say, 4. Oh, sorry. I'll keep the vertical resolution as it is. I'll just change the horizontal resolution by 3. Okay, so the same model has been now revised to 380 by 240. Okay, maybe we'll revise this further. These are much smaller model now. Okay, so maybe if you have workspace, smaller workspace, okay, same, if you want to use the same database, we can use this change of resolution to import the models. Okay, meaning one grid size will be 5 meters. Okay, so if you keep one grid size as 1 meters, you can see this is the actual scale. Okay, 1156 by so and so. So this is a 1 meter resolution. If you increase the resolution size of the grid or decrease the resolution, you will get a smaller grids. Okay, so depending on the scale of assessment that we can set this. I'll just create this because we're not going to use this as a base for running our simulations. But let's see. Okay, so once we have created the model, it's taking time. Hmm. Nothing is saved so far. Yeah, just save. Oh, this only this area is what we are interested in creating the model. Mhm. This otherwise, if we don't assign this here, it will take 2,500 to 2,500. Yeah. So we just have to say, yeah, we can do that here by saying sub area. Okay, we have multiple. Okay, so we have, I think, multiple times I've created. So we have this now. What I do is I'll just try to export this into INX file. Hmm. Okay, now I've exported the model. Now I'll go to headquarters. Let us go to the main actual model area. Okay, so we'll be starting from here, but I thought I'll just show you there is a possibility of directly bringing the model as well. We can use it as a base. Yes. Hmm. We can directly draw also here in Mont. See, Mont. here, uh, uh, here we are directly making the simulation model. Want also we can directly, we can, yeah, yeah. The size is yeah, buildings are much. Hmm. 4 meters resolution. Okay, so there's a possibility. Okay, so maybe if you have a higher version, okay, then we can bring in the 6 months. Okay. Maybe let's see if I export only one of the buildings. Hmm. Buildings are there. Buildings are there. Too many exports. No, I think I'll just stop this here. Okay, there's a possibility, okay, of bringing higher models. Okay, you can check check that. Now let us go to the main part. Okay, spaces for modeling. Okay, let's go to spaces. Okay, so by default we have this 50 by 50 grids. Okay, that's where we will be trying to work. Okay, so make sure that you're putting the models in the appropriate uh, model folder. Okay, before you edit, before we move further, you can set certain things. Edit, go to edit area, and define the areas. Define the settings. Maybe By default, is Germany. Let's say we go to Vijayawada. Okay, set the city where you want to do an assessment. Okay, so other things you can leave it as it is. Model. This is important part. Okay, so we have this grade 50, 50, and 25. Okay, so this is used for scaling. Maybe let's say you have in this grade 50, 50, 25. You can model a study area of 100 meters by 50 meters. Okay, this is 2 times. Okay, so if you want to make more, let's say you want to scale down further, you have to scale it here. Okay, both in this is in x and y and also on the z. Okay, so ideally, like I said, leave at least 1/3 of the entire space for models. Only then we'll get a proper output. Otherwise, we'll have a lot of issues in that. Okay, and there's something called uh, telescoping also, meaning, for example, let's say in if we read the theory part, it says this is our urban environment, okay, and the atmosphere is divided into certain levels, okay, and this level and this level is not same. Okay, this two level is not same as the above levels. Okay, there's something called there's a mixture of layer and there's some the technical words are there. Okay, and that is taken into account in ENVI-met model. Okay, whatever simulations, whatever assumptions that we are making is we are trying to moderate only this part, lower part of the built environment. So that can be moderated here using telescope and so on. DEM, I think we are not doing it now. Let's say if you have topographic data that we can bring in, and you can use it as a base. By default, you can start with certain more wall materials and roof materials. Okay, so maybe to begin with, let's say walls are made of concrete and roof is also made of some heavy concrete and so on, hollow blocks, and wall is made of roof material. We can assign that later also, but you can, if you have to assign, you can assign that here. And also you can assign some, what is the entire space is made of. Okay, it is sand or what type of sand, what kind of land, you can assign it here, or we can do that later as well. Okay, by default, sandy some value is assigned, but if you know the soil property, we can assign that specific uh, uh, material to the entire workspace. And in fact, if you go to the details, soil can be modeled for up to 15 meters. If you take out these sections here, um, these are for each you can change materials. Okay, these are layers. All layers can be modified if you have information. This entire section can be modified. First 10 centimeters, what is the soil condition, what is next, all that can be done actually. Okay, so we have checked this. Let's say create layer, create. Okay, so once you define the space, okay, we have a workspace now. In this workspace, we have these tools are used for zooming in, zooming out, and we have 3D visualization for This is for 3D visualization, and this is the entire frame in which the entire model will be made, and we can visualize this. And only point to be remembered is we should not touch the boundaries. Okay. Theoretically, it should not touch the boundaries because to avoid errors. Otherwise, we'll have errors in the results. Okay. So let's go to the base. And on the side, we have certain things. One, what we can do is we can bring a bitmap. Let's say already you have some file. Maybe I'll just check if there is one. Let's say we have a bitmap. Okay, you can directly bring that. Only thing is, please make sure that you know the somewhere you write the width. Okay, because we'll not get to see what is the width here. Okay, somewhere when you download the drawing itself, you measure it here and write it. Maybe this is 5 meters or 3 meters. Accordingly, we can adjust whether the entire bill, entire the image has to be stretched according to the grids, or whether it has to be shrunken, so on and so forth. Okay, so one you can do. You can bring in the bitmap and then you can start tracing. Okay, that's one way possible. Okay, I'll just show this. So we have this entire space. Maybe let's say if you are trying to study only this part, we can try to do that. Okay. Or let's say you just have to make some basic model. What I'll do is let's see how we can do it, some basic outputs here. What are the things that we should model? We should model building, we should model vegetation, and probably we should model these soil surfaces. Okay, rest of the things we can define it later or as we move further. Okay, first thing, building. If you click on building, we have two things here. Okay, one is building and building NR. Okay, if you go to the building, and by default you can see the building height is written as 5 meters. Let's keep that. What is building height? Bottom of the building height. Suppose if you have a stilt, okay, and you want to model the stilt also, you have to assign it. 0 means the building is resting on the ground. If you put 1, meaning the building is above 1 meter from the ground. Let us assume it is there on the ground itself. Okay, and we have also by default we have let's say we have assigned some wall material. Okay, you can modify this. Assign what is the material made of. Okay, and what is the roof material we have already assigned, or you can assign it here. Okay, so then we start the model. Okay, what I do is I'll just start drafting here. Okay, let us say I'll put another building which is 3 meter, which is adjacent here. This is another 10-meter building, maybe. This is one building. One is like a step building kind of thing. Okay, so we have this 10 meter, 5 meter, and 3 meter building structure. Okay, now I go to soil, maybe. Okay, so let's say in front of the building, there's some material, I'll say concrete like pavement. Select that and you start applying. Okay, and let's say I'll add a few things. Maybe I'll add some vegetation. So vegetation part, I'll add maybe a tree. Okay, let's say this is how the trees are. Okay, and okay, fine. And probably I'll add little more material. Okay, fine. And let us assume we have this asphalt road just beside our pavement. 1 meter. Once again, I'll just check. 2 meter between. It's a 15-meter between. Yeah, 2 meters. Okay, so this is one of the output. So this is one of the base required. Okay, so we we make models like this. Okay, to directly make, and I don't think we'll be able to make directly a realistic neighborhood like this. But you can bring in the satellite image, or you can bring in the CAD output, and then bring it here and then trace it. Building your surface material and vegetation. Okay. Once this is done, okay, save this model in the appropriate place. Okay, so we have one INX file created. Okay, let us assume that we have done with the model. Okay, what is the next step that we need to do? Once model is done, we have we can go to NV guide. Okay, NV guide, like I told you, this is the tool where we create this simulation files. Okay, I take, yeah, the same folder, and you can see here it says when the simulation should start. Okay, maybe certain dates are given here. You can assign specific months and dates when simulation has to start. When is the date of simulation, and when the date, when the hour, when the simulation should start. At what hour the simulation should start, and what is the simulation time. Okay, many times what has happened is we forget to change this 24 hours and we leave it. It will take 12 hours, 18 hours also to run. We'll feel that we're not getting results. Yeah, if your system is fine, maybe it may take 8 hours or 5 hours to generate results, but otherwise it will take ages. It will keep on running. It should be like that. Uh, that's a tricky question. If you have good system, yeah, you can simulate for longer time. Longer simulation, better results. Let's say if you want results for 1 hour, it is generally said you should take 1 hour before, 1 hour after. In between should be your results. Okay, because the setting time of simulation, it's like a preparing cooking only, sir. In the initial stages, there will be some maybe slow application of force till it takes few minutes or few seconds and few minutes to achieve this actual force. So generally, if you are simulating, let's say your results are dependent on only 1 hour, my suggestion will be should be to simulate for 3 hours. Okay, so that you have some results in the beginning and some results afterwards also. Yeah. Name of the simulation, let's say, to test save appropriately. Okay, and it will, yeah. In fact, I'll not run simulation at all. Let's see. Okay, load INX file. Okay, so before we come here, we need to have a model here. Only then we'll be able to generate the results. Okay, so once we have done this, okay, so this is one thing. Second thing, I said, if you click on this meteorology, it says three things here. Okay, one is simple force. Okay, use full force or use LBC. Use simple force. If I click here, okay, you can see the parameters are very limited, and we can, let's say, if you just want to depend, or if you want to simulate only based on the results that we have, let's say, you can modify the air temperature, you can modify the humidity, okay, and then you want to simulate using this model. Okay, and some basic things like what is the wind speed, wind direction, and what is the roughness length. What is the roughness length? Roughness length means, for example, let's say if you're simulating in urban areas, there's more roughness, meaning there is no space for ventilation. Okay, so lesser the roughness value, meaning it is more rural. Okay, here roughness is not the surface roughness, it is the ventilation roughness. Okay, so you can use that simple force, or you can use full force. We can we can we can assign what is to be uh, what is to be simulated and how. And if you go here, we can define certain boundary conditions as well. Okay, so there are three things. Okay, you can simulate with the simple force where you have these basic information in hand. And also, if you see here, you have additional information here. Okay, and we can assign what is the soil conditions like. Okay, or if you want to have, if you have some recorded solar radiations data, that can also be part of this. Or you have building indoor temperature, or if you have measured things, that can also be integrated pollution sections. Okay, so if you have monitored some primary data, and if you want to keep that as an input, that is also possible here. All types of pollutions and plant sections. Uh, when this is more like operational window also, for example, when you simulate building, we say when is the operation time of window. So when the when we can expect the results from the natural conditions can also be given as input. Okay, so using this, we will create a SIMX file. Okay. Okay, so we using space, we have created the model. Using ENVI-met, ENVI guide, we have created the simulation time, and we go to ENVI core where the actual simulation takes place. Please make sure that you assign that particular folder, and it will check for errors if there is any error or okay, project is loaded and there's no error. Okay, otherwise we will get a hint that some error in the model is here itself before we actually run the simulations. But we still don't know. We have to check whether this is satisfying the conditions or not. So we have the model. You can see it has read it and it is checking whether there is any error. Let's see. No, but by default now there is in trial version. Okay, so finished. So there's no error. Otherwise, we will get a prompt here itself that there is a possibility of error. Okay. Anyway, I will just run simulation and then see whether it makes. It will take time. Okay. It will not be that easy. Let's see how much time it will take. And we will get an progress bar here, and it will tell you how much time it will take for simulations. Okay. So let us, meanwhile, what we'll do is we'll proceed further. We can't wait for this. Okay. So space for modeling, NV guide for assigning the time duration of the simulation. Use NV core for uh, for the simulation itself. Then let us assume that this has generated results. Maybe I'll show you the files. Maybe it should have already created the files. Yeah. So the files are getting created now. You can see atmosphere, building, radiation, soil, vegetation, so on and so forth. Okay, results are getting generated. Once the results are over, we'll be able to use this particular data. Okay. Assuming that we have run the simulation, how do we read the simulation results? You have to go to the another tool called Leonardo. Okay. After going here, please make sure that your assigned files are correct. I'll open up some old simulation results. Okay, there are so many output you will get to see. Okay, maybe I'll, this is 1 hour simulation results. And you can see once you open the Leonardo, okay, and if you once you open up the output results, you will see which are the results for which you have the output. Okay, in this case, we have output for only one of the hours. Okay, so maybe if you have simulated for more hours, you will get to see blue tag. Okay, you have results for all those. Okay, I'll just click extract. Then I go here and then maybe I'll say let us go temperature and maybe I'll use wind speed as contours. Okay, and you will also see here position of view plane. Actually, we can do assessment at different levels because it's three-dimensional thing, right? So k value 0, okay, maybe if I put k value 1, it means you can see here it says it's zero point 0.6 meters from ground. If you want to do an assessment, let's say at 1.5 meters, sorry, 2k, okay, so it means the assessment result will be for 1 meter above ground level. Okay, so based on your requirement, let's say if you are assessing thermal comfort and all, you assign the layer 1.1 meter is what we say, right? So 1 meter level, you keep the k value as 1.2 meter 2, and it will be at 1. The results will be at 1 meter level, and create extract. I think this is also a dummy model that I have made some time. Okay, so we'll get an output building and what is the temperature profile like. I have plotted temperature, so it is showing temperature. And these are the, there are different settings that can be modified here to read this in a better manner. Maybe text you can bring in. Okay, you can modify the labels, scale, all that using here. Access. Okay, these things are not very complicated. I'll just tell you one thing that can be checked. Let's say if I go to the data layer, okay, so there is a possibility of using different presentation techniques. Okay, this if you want to make the divisions every time, what you have to do is you have to update it. Okay, there's a small icon here. Any modifications you want to make here, just press update. You will be able to see. I'll make the labels as also 5. Let's see. Okay, so we have a temperature below 20 degrees Celsius, and okay, the range is too less. Okay, you can do autofit. Maybe what I do is we can bring, there's something called these are actually the uh, building vegetation layers that can be checked here, and how it can be presented. You can bring in vector data. That's one thing that interests. These are wind directions in this plot. For example, I go to vector setting and let's say create random winds, and maybe okay, so this will help in understanding of how the airflow is and so on. So these are not realistic model, okay? It's just for showing how the results are to be done. Maybe we can plot other information also. We can plot, in fact, all this information that you see here, okay? Other thing is, if you right click on this space, of course, you can save this. You can export this into image. All that is possible, okay? You can export this as a bitmap file and then use it. If you right click on this simulated area, there's something called, you can explore the grids. Since we don't have comparative results, we are not able to see. For example, let's say we will be, if you have two sets of data, we will be able to compare here itself what is the output like. Okay, so we can do plotting for all this information here itself. Or you can export whatever it has simulated into Excel file. I'll show you this. And then we can, so these are, this is only 1 hour, so we don't have any comparison to make. But these are the variables for which simulations has been done, and then we have some values for each of the variables. Okay, so that we can use and interpret. Okay, and you can also do one more thing. Let's see. All the variables, whichever variables that you want to plot, you can extract. Okay, maybe I'll keep uh, K4. Okay, so at 4 meter level, so not 4 meter, 1.8 meters level, what is the outcome like? All that can be simulated. Yeah. Okay, I think there are many things that can be said. I think to start with this should be fine. And yeah, I think we'll start with this. Maybe if you start trying, okay, there'll be a lot of initial problems. Once you get to this, I think you're done. Now you have to have you apply your understanding and get the outputs. Yeah. Okay. I think this is still simulating, but I don't know how much time it will take. But yeah, about 50% is done. Okay. Once again, thank you, ma'am, for the opportunity. It is actually good, so good for me. I have to practice before I come. So in a way, I don't know whether we don't get to use it. Thank you, ma'am. And if there are any questions, yeah, I'll be happy to. Yeah. We have to go in. We have something called force. Yeah, it will be EPW5. It will be EPW5. Yeah. Okay. So what will happen is you can import a CSV file or you can import the EPW file. Suppose I take some EPW file. Okay, so we have values for all this. Okay, so this can be used as your file. Save this as force file. Okay, you can add your own files here. Import. You can bring that FOX file. Yeah. Yeah, yeah. Yeah, there's only one layer available for water in the same thing. Mm, there's only one layer. Okay, it's like in the same soil layer. There's a water. There's no. So okay. Uh, yeah, I have one. I don't know whether it is the correct method. Let us say we have only 50, 50, 40. Okay. What you can do is, no, no, you go to them. Okay, we can create. No, one second. I'm assigning this area as, let's say, 3-meter level. Okay. This part of my grid is, let us assume it's 3 meter. Okay. And let's say rest of the, before modeling, okay, before you make a 3D building, you can assign this land as, let's say, 2 meter, and this part as 1 meter. Okay. So you will be able to see the levels in the model itself. Okay. So there is a 3 meter land, 2 meter land, and 1 meter land. On top of that, you make buildings. Yeah. Okay. Let's show introduce that. I I thought I'll just show the image. So I didn't prepare a drawing. I'll just show. Okay. For your exercise, maybe when you start developing, what you can do is you can go to Vijayawada. Sorry, we are very biased, okay, about Vijayawada. So do something about Vijayawada. You can take out this part. Hmm? You can take out the campus where we are residing. Okay, it's about 7 acres, 8 acres, including around 10. Yeah, let us take only this campus. Okay, maybe Google will be better than this. Okay, so I think you can model this part, this entire campus part. The advantage is we have a road and some buffer of green, and again we have paved surface and big building. And on this side we have some green, okay, paved with green, and again we have blocks. and in between we have some shades, different aspect ratios, so on and so forth. So what you can do is you can prepare a base map for this entire campus, and then you can maybe to start with you create maybe 3-4 layers only, maybe road, major one. Second, the pavements, concrete pavements are there. That can be a second type of layer. Third type of layer, we have some greeneries and then pavers. Okay, so you can have three types of soil finishes. And then we have vegetations. Okay, you can just go around, check what is the height, size of the vegetation, and then you can assign that. And of course, building height is 25 meters. Maybe if you keep two grid size, you will be able to accommodate 12.5 meters. You should be fine. Should be within the free grid size that we have. So if you can simulate for this, it will be great. Also, you have taken some measurements today, right? Maybe you simulate for today and see what is the. Hmm. Hmm. Uh, we can only edit it. It's only partial. If you run, we have to check that. Yeah. Okay.
So, on behalf of everyone present, I extend our sincere gratitude for enlightening us, sir. Thank you for dedicating your time and sharing your profound insights and perspectives you brought to the program. And now I would request Dr. Lily Rose to present the memento to Dr. Fayez, sir. Uh, Actually, it was a very technical session, long session, but then lot of information has been given. It will take some time for us to digest all that and then apply it in the model. Next, I think we can move to the lab. In the lab, all like there are few systems that have been we have installed ENVI-met light version, so you can start modeling this. First, create your folder as the step. So slowly, first explore all the comments on top, and then see create a folder. And probably in the due course in the next 3 days, you can create your model. Create a smaller version, and then try at least you run one simulation for you to understand whether you are able to run the simulation. You may encounter problems. To start with, I think we can start with the EPW file, and then you can do simple forcing and then run the model. That'd be easier. Yeah, tomorrow afternoon. So we have tomorrow after the morning session we have one hour. Then after the no afternoon we don't have Wednesday, but Thursday again we have one in the morning and one in the afternoon. Again Friday we are having sessions. So the end of first day you will be presenting the simulation, uh, the results of this. Yeah, you can also work on that. But to start with, I think you take a simple building block and then you can run it. You can either simulate our institute or if you want to do for some other block also, you can do. I think the tea has been there for quite some time. Let's go have it before it become cold already. But then we can have and then we can move to the lab. Maybe you have 45 minutes to at least explore the comments. We'll just move. move fast to the lab so that you have at least 45 minutes straight. Thank you all. Thank you, Dr. Fayez, for such a intensive session. Thank you. Strong. Yeah. First, actually, yeah.
So I'm also happy. Otherwise, we are not working daily, so I just leave it for some time and use this.